We kind of covered this already, Tannen. We got this, all right? What is an integer?
A whole number.
Okay, perfect. Whole number. So, heavens to Betsy. Ah! Buttons. Here we go. I promise. There we go. All right. Next question. Is 0 considered an even number?
Yes.
Does everyone
No.
agree? Oh,
No.
0 is 0.
No.
0 is 0. Okay. So here's a question. What is the definition of an even number?
And even no, never mind. Let me just turn off my.
An even number is a number divisible by 2.
Okay.
Oh, that was
Is-
so insane.
Is 0 divisible by 2?
Hush. I tried, okay?
Okay.
You divide 0 by 2, you get 0. Or you
There
get
you go.
Anything
Zero
times 0 is 0.
0 divided by 2 is 0, which is a nice integer. So 0 is considered an even number.
Huh.
0 is also an even number because I was always told, like, for double-digit numbers, like when I was younger, a way to help you know if, like, a double-digit number is even is if it ends in an even number. So, like, 38 is an even number because it ends in an even number. So 30 and 40 and 50 are all even numbers, and they end with 0. So does that make 0 an even number?
Yes, it does. That is a great example. Okay. Next question, is 0 a positive integer?
Now, that's a good question.
Isaac's doubling down with his no.
That's a very good question.
I think yes.
Well, yeah, I say yes too.
I think no.
Okay. So 0, is 0 negative? If it's
No.
not positive, is it negative?
Oh,
No,
it's its own thing.
just because it's not in it.
It's not positive and it's not negative. It's like slapped in the middle.
Yep. 0 is kind of special. It's neutral. It is neither negative nor positive. They consider it a non-negative. It's its own little category. All right. Is -5 an odd number?
Yes.
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 Doesn't matter if it has a positive or a negative. As long as it's like a 1, 3, 5, 7, it's an odd number.
Perfect. Positive and negative does not change whether it's divisible by 2 or not. So, -5 is considered odd. And our last question, is the number 1 a prime number?
I don't know, is it?
That's what I'm asking
yes.
you. Okay. What's the definition of a prime number?
I don't know, I was just about to ask that.
1 is not a prime number.
Yeah.
I think a prime number is a number you can only divide by itself and by 1.
Perfect. A prime number is divisible by itself and 1. So, is 1 a prime number?
No.
No.
Yes.
Yes. Yeah, it is.
Is it divisible by itself?
Yes.
And 1.
Yes.
Yeah?
He went silent and I was like, oh man.
I did go silent because the answer is no.
I told y'all.
Okay.
Dang it.
It is only divisible by 1. It doesn't have a second number. It has to have 2 distinct numbers to be considered prime. Like 2, you get 2 and 1. 3 is 3 and 1. 1 is only divisible By 1.
Oh, because it's like if you divided 1 by 1, you get a half. You wouldn't get a whole number.
Okay. So, with these facts in mind, knowing what an integer is, even versus odd, prime numbers, I got a challenge for you. Here is a problem that you could use our previous strategy on. So we left talking about using the solutions to back solve. Okay, and to answer Kristen real quick, 2 is the only even prime number. So 2 is considered prime. All right, so remember, back solving. I'm giving you the answer. Use that to your advantage. See what you can do with this next problem. There you go. Okay, a couple questions or words that we haven't specifically mentioned. What is the sum?
Addition.
Okay, sum is addition. What does product mean?
Multiplication.
Multiplication. All right, so you're going to take 5 numbers, add them together, take those same 5 numbers, multiply them together, and those numbers should match. Okay, so like I mentioned, this would be a good example to back solve. Okay, they gave us a few examples, so I'm going to start at the top. They told me the greatest number was 4. So I'm going to go backwards. 4, 2, 0, -2, -4. If I were to add those all together, what would I get?
0.
If I were to multiply them together, what would I get?
0.
So my answer is
0.
0.
well, the sum and product is 0, but my answer is going to be 4. Okay, with this one, they're asking what was the greatest number? Well, the greatest number, they've given me my options. So I start with it and I back solve. If you would have started with any other, say you picked E, I saw a couple E's popping up, 20 would have been the greatest number. So I would have had 20, 18, 16, 14, and 12. If I add them together, is that the same value as if I multiply them together? No way. Okay. Belle, I'm seeing that you're a little confused. Do you have a question?
Ooh, man.
Okay, so real quick again, just to kind of visualize what we're looking at, they asked me for the greatest even integer for 5 consecutive integers. So if we would have had 20, we would have had 20, 18, 16, 14, and 12. I want to be able to add all of these together And that number should equal the same thing if I were to multiply these together. And the only way that works is if we incorporate those negatives and 0.
But no way.
Yes way.
What do you mean?
Mind blown.
Because if we add these 5 together, we get 0. And if we multiply these together, we get 0. I need these two numbers to match.
Now, why do we go backwards?
Because, so the reason we're going backwards, if we go back to our problem here, it wanted to know what was the greatest of the 5 integers. The greatest integer was 4. So if we go back to the whiteboard, what I did is I said, all right, if 4 is the greatest integer, then I need to find the next even numbers. 4 is the greatest integer in this list.
Well, if you have it, I have it. Because I see you literally every day, but you probably don't.
Okay, guys, make sure you're on mute unless you're answering a question. All right. Katie, I hope it's a good hurt because we're learning lots here. All right, let's move forward. So we've been doing back solving. We've tried picking numbers. We've tried back solving. We've got a couple more strategies to look at. Okay, guys, make sure you're on mute. Zoom kind of works like walkie-talkies. If someone else is talking, they can't hear me. All right, here's a nice wordy one that I don't really love wordy problems. So when we come across a giant wordy problem like we see here, what I tend to do is I start to read the question first, and then I just go find the information that I need. Okay? So here, if we read the question, down here it starts saying, what will be the degree measure of the other sector? Okay, well, what does other sector? So right here, it says the colors other than red, blue, green, and purple will be grouped together in the other sector. All right, so we have 25% red, 30% blue, 20% green, and 10% purple. Okay, this problem is a good way to show or use drawing it out to help you guess. Let me show you that on our whiteboard. So if I don't really know how to answer that question, it says that they wanted to create a pie chart, and that was the information I was given. So a pie chart has to equal 100, right? We need 100. We have 25, 30, 20, and 10, which means we're missing 15%. Okay? So that's doing the straightforward math at this point. Okay? But if we were to say, look at our pie chart, if I know 25% is already taken up, that is a quarter of my pie chart gone. Then I have 30%, which is a little bit more than 25, so I'll put it there. 20 is a little bit less than our 30, and then we have the 10%. Again, these are just rough sketches. I need to know the angle of this sector. But if I don't know much, okay, again, I'm doing this because I don't know how to do the math. I know that this piece is 90 degrees because it is a quarter of the circle. This piece, if we look at our answer solutions, I'll toggle back here in a second. I know this is 90, so this piece has definitely got to be less than 90. So let's jump back real quick. Well, we've got 108, so that's gone. And then everything else is less than 90. Do we see a trap? Is there a trap in our answers right now?
15.
15 degrees. We found the 15%, but 15% does not equal degrees. So if we could eliminate the 15, 10 seems a little bit small, 108 seems too big. We're at a 50-50 guess at that point. So this method is trying to show that we can go ahead and sketch it out to help us estimate our answer. But as Tannen is showing us in our chat box, we know that we need 15%. Well, 15% of what? The 360 degrees. So if you grabbed your calculator and you said 360 degrees times 15%, which is 0.15, it's going to go ahead and give you that 54 degrees. 360 is a circle. Perfect. Yes. So this method, again, I want you to put your pencil to paper. As soon as you pick up your pencil and you start writing on your test, your brain's going to start firing neurons everywhere, and it's going to help you figure out more answers than you would have if you just sat there and tried to think it all up here. Okay? Putting it to paper really, really helps your brain get going. So, this question we just went through, we get our 54 degrees. Questions on this one? Okay, cool. So again, this method is when in doubt, draw it out. So we've got one more to give that a go. See what you can do with this one. I'll give you a minute. Here you go. All right, I'm seeing us toggle between D and C at the moment. Okay. What does it mean to be inscribed in a square?
Like the circles inside the square.
Okay. So inscribed in a square looks like this. My circle is inside my square.
No, you gotta like fill it to the edge. What do you mean, bro?
What do you mean, bro?
This is unlike usual.
You can't just put the circle in. You gotta put it
Can't
to the
be
edges.
a dot. It's got to be like a square donut from Lee's.
A square, they make those?
Yeah.
Yeah, they're good.
Very strange. Okay, so the circle has to touch the sides, and then they've told us that our square is 8 meters. How does that help us? Who cares?
Because it tells you the diameter of the circle.
That means this is 8. How does that help us find the area of a circle?
This might
Because
be
then you
completely
can-
unrelated. I'm sorry, but I was under the impression that it was centimeters and not meters.
It is centimeters, but
Thank you. Okay, that tells us our radius is 4. And how do we find the area of a circle?
By pi?
Pi r squared.
Perfect.
Yeah.
So, if my radius is 4, 4 squared is
16.
beautiful. All
Oogity.
right. Here comes some entertaining math test taking entertaining thoughts. We are going to talk about guessing. Okay? This comes into play either you're over it and you just don't want to think anymore because your brain is fried. 2, you're running really short on time, so you're going to do your best to eliminate so you can get better at guessing, like more accurate, I guess. Or you don't know how to do the math problem whatsoever, so you're going to use these rules to just try to eliminate some of the options. Okay? The first rule here, look at the range of the answers. So if they're all within a range, that's going to be harder to guess. But they might toss in a really small number that does not fit the other 4. Get rid of the small one. It's an outlier. Or if you have nice numbers and then a really big number, get rid of the really big number. Their goal is to try to hide the answer. So if you're just guessing, get rid of the ones that stand out, those outlier numbers. Too high or too low. Don't go in and automatically get rid of the highest and the lowest, one or the other. Okay? Then you're also going to look at the length of the answers. So if they're all really, really short and then there's a long answer, get rid of the long one. Or if they're all nice and complicated and then there's one that seems way too simple, get rid of the simple one. They're, again, trying to hide the answer. Look for a pattern in the answers. If there's numbers in there that don't follow the pattern, get rid of them. They're not blending in, they're gone. And lastly, we've talked about this one already. Go ahead and eliminate the cannot be answered as a choice. Just get rid of it. I have seen that only be an answer on a test once in 7 years. Okay, so just go ahead and eliminate it. It rarely works. So we're looking for patterns. We're going to try to get rid of the ones that don't fit the pattern. And then we can use the problem that they're actually giving us to help us eliminate further. Okay, so I've got, I think, 3 questions after this slide that are built for us only to guess. I don't want you to read the problem. I should even just hide it. Future reference. I'm going to hide it. We're going to look at the answers, and we're just going to try to find the answer by elimination. And then we can take a look at the question and see how we did. Okay? So this next one, we've actually already seen this problem, but I want you to try to use this thought process or see if you recognize how that could have helped us in this situation. So, again, we've already seen this one, but just look at the answers. We need to eliminate and try to find our answers. What are we going to eliminate?
50 and 25.
Okay, 50 and 25. Why, Michaela?
Well, 50 is the obvious, easiest answer.
Mm-hmm.
And then 25 just doesn't fit.
Okay. Why else could we eliminate those 2 and keep the other 3?
They don't fit the pattern.
The pattern is you have the 6 in the ones place, and those two don't have that.
Yep. These ones end in 6. 26, 36, 56. Get rid of the rest. They follow a pattern. My answer is probably one of those. Okay? And again, we've already done this one. We know that the answer was E. And yeah, we already solved it, so we knew that to begin with. But that's a good example of seeing that pattern. Okay, this next one, again, just look at the answers. Don't look at the problem. Think it through and see if you could try to eliminate. I'm going to give you 20 seconds. Try to actually pinpoint and say, I'm picking B, I'm picking D. Pick your number by only looking at the answers. Yeah, we would only know the actual information if we looked at the question. That is very true. Don't pick C yet. No, you can't pick. Yeah, we haven't even moved to the new problem. Okay, stop. New problem. Here you go. Pick. Good job, Dennis. Just look at the answers. Just look at the answers. Pick the right answer. Elizabeth.
Would you eliminate F and H?
Why?
Because the other ones have 3x and an 8, and those two don't.
I could agree with you there. Yeah, I like that pattern finding. Okay, I'm seeing eliminate K. Why are we eliminating K? Isaac kind of already answered it for me. Kristen did too. Okay, so we're eliminating K because it doesn't, it's complicated. It seems too hard. It just doesn't really fit what we're looking at. What else can we eliminate?
Both F and H, because those don't have a -8 in them.
Okay, I like that. They don't have the 3s or the 8s, so F and H are gone. So we have G and J left. So G and J, and if we're just guessing, what are we going to guess?
G.
G.
It's simpler and would be more difficult with the 2 x's, I guess. I don't know.
Yeah,
Okay.
that's what I would think too.
If we were to jump up and just even glance at our problem right now, we have this one number in there and it says 8 fewer sharks. How would you show 8 fewer sharks?
-8.
I would -8.
Yo.
Okay, so that's an example where you can just go through. We didn't even read the problem and we got it right. That can happen a lot on the test. As long as you recognize patterns, you work through it, you can just guess your way to these answers. Okay, here's one more. Again, just look at the answers.
We can get rid of E.
Yep, agreed. E is gone.
And A
Why A?
is it's the only one with a decimal.
Decimal. Yeah.
A demisel? Agreed. A gone. So we've got B, C, and D left.
I would get rid of D
Why?
because like 15 and 20 are pretty close, but 30 is like more out of range, I guess.
Okay. And I mean, in general, 12, 15, and 20, those are a lot closer than the 30. There's less of a gap there. So now we're down to B and C.
If you glance at the problem, it says the number 4, and the only one that's divisible by 4 would be C.
And our answer
C.
is C.
I just didn't look at the problem. But if you do look at the problem, there is a 4 up there and it's divisible by 20. So.
Yep, exactly. Okay. So again, just ways to look at problems. I could go back now and show you multiple problems that we've worked through, and you would see easy ways to eliminate down to the answer. without even doing the work. Okay, it just takes practice to kind of go through it and to trust yourself to make sure that you're, you know, guessing appropriately.
If I had known this on my first test, oh my goodness, that would have like saved my life in so many ways.
So I've taught this class multiple times, and I mean, I used to work for BYU and they would fly me places to teach this lesson, and almost every kid told me their favorite part was learning how to guess. So hopefully it's helpful. It'll, you know, up those scores a wee bit, but the rest will help too. This is why we have a ginormous book, so that we can guess. Now you have plenty of practice tests to go in and guess. Just referencing the book, because I'm not going to be able to cover every single math topic today. If you guys have the 2020 book, you have over like 160 pages of just math. So if you like struggle with geometry, there's a geometry section. Get in there, review it. If you're struggling with vocab, there's a vocab section. Go in there, review it. Okay, I'm trying to cover hit and miss here, but you know, I can't teach you 11 years of math in an hour and a half. Okay, next problem. It's a surprise because I don't know what's next either. All right, a review. This is what we've talked about this morning. We just finished it up just now. Remembering your math skills, do the straightforward math. Pick numbers. Pick numbers if the problem is abstractly hard. Back solve. They've given you the answer. Plug it in until it works. Easy. And, of course, guess. I've had kids that just went into practice guessing and they got to a point where they were guessing like 70% or above every time. So it's a good skill to have. Well, I'm glad I could help you with some math. That is my goal in life. So I'll see what I can do with the remaining 44 minutes I got you for. All right. Here's a question. What is the difference between factors and multiples?
Ooh, factors and multiples. Learned this a long time ago.
Mm-hmm.
Factors would be things like
Multiples,
1
it
and
can be
6,
like
2 and
multiplied
3.
into.
Reese, what
All right, my
takes?
factors.
Reese, what
I thought
takes?
multiples were like the
What?
numbers that can be multiplied into 6, like 1, 3,
Hey, Reese.
2, like those
Reese.
kind of things.
Reese.
Switch that. Okay? Our factors of 6 are only 1, 2, 3, and 6. Factors are what multiply to create a number. Okay? And a multiple is what you can multiply to 6. So we can get 12, 24, 18, 600. Multiples grow from 6. Factors are what make 6. Okay? So we're going to do a couple practice problems. Factors versus multiples. We've already covered the word prime, so we'll see if you can use that on this next problem. So I'll give you a minute to look at it. You guys should be doing your math, not looking at what I'm drinking. All right. Prime factors. What is a prime factor?
The biggest number that can multiply to 6 to the number like 51 or 75.
I haven't tried the BlackBerry one. I'll have to give it a go. So we are looking at the number 51. What are the factors of 51?
1 and 51.
I love hearing that, but I am also sorry to say
3 and 17.
we needed those. 3 and 17.
Do they get homework?
The trick on this problem is they want you to assume that 51 is prime. But 51 is not prime. I'm going to show you a trick here in a second. But it is divisible by 3 and 17. 3 is prime, 17 is prime, so we're good. Okay? And then we have 75. What are the factors of 75? So I got 5 and
3 and 25.
okay, so we'll go ahead and let me erase it. Whee! Cool. So we got 3, oh, there we go. 3 and 25, and then the factors of 25 because 25 is not prime.
5.
All right. So we need to find the greatest factor, prime factor of 51, and the greatest prime factor of 75.
Wouldn't it
Don't rub it in, Quinn.
because they both have the number?
No, so they want the greatest prime factor of 51, they're going to call that A. And then the greatest prime factor of 75, they're going to call it B.
So
17.
51 would be 17, and then 75 would be 5.
Yep. And then we add those together.
22.
And we get 22 as our solution. So this one was a vocab question to make sure you understood what a prime factor was, and then just do what they want you to do. All right, here's a little trick here, because the problem with this question is they wanted you to fall for the assumption that 51 was A. They wanted you to think 51 was prime. What's 5 plus 1?
6.
Is 6 divisible by 3?
Yes.
Then 51 is divisible by 3.
Yes.
Oh.
Okay. If I gave you the number 312, if you add those three numbers together, again, we get 6. If 6 is divisible by 3, 312 is divisible by 3. Okay. 507. Is it divisible by 3?
Yes.
5 plus 0 plus 7 is 12.
Yes.
12 is divisible by 3, so 507 is divisible by 3. Okay. Switch that up just a wee bit. I'm going to change the number to 577. Nope, 567. Don't judge me. 567.
Yes.
Okay. This equals 18, which means it's divisible by 3, but because it's 18, 18 is divisible by 9. So 567 is divisible by 9. Okay? Cool little tricks to help you with the factoring, just to make that a lot easier than just jumping on a calculator. All right. So if we jump back to our slide, we had A plus B gave us 22. All righty. All right, So we're talking factors and multiples. Here's your next problem. What is the largest, or is it the least? What is the least common multiple of 10, 15, and 40? You will be able to use a calculator on the test, yes. But you got to bring your own. They're not supplied. Okay, so remember, we're talking multiple now. What is the least common multiple?
H.
Okay, so we've got the vote for H, I heard that. Dennis is telling us it's 120 as well. Seems like Isaac might be supporting Dennis with his hashtag in there. Dennis, don't be weird. Elizabeth, your computer really hates me, doesn't it? Okay, for it to be a multiple, that means the number we're looking at has to be divisible by 10, 15, and 40. I'm glad you don't hate me, Elizabeth. I do my best. Since it says least, I go ahead and start at the top. Is 10 divided by 15? Nope. Is 80 divisible by 15? Nope. And then you look at 120. Is it divisible by 15?
Yes.
Yep. Is it divisible by 40? Yep. Do I even need to test 10? If 40 works, 10 has to work. So, boom, we get H. Okay. And again, that was an example of back solving. They already gave me the answer. I'm just testing it until it works. What, Quinn? Could you just take the zeros off so it was 12 and 4? No, because then we would lose the 15. But I mean, 12 and 40, yeah. You end up getting the 3, yeah. Yes, J does work, but it's not the lowest, and I believe K works as well. I haven't tried it. Let me pull up my calculator. Yeah, so H, J, and K all work. So then that one just comes down to remembering it said least common multiple. Okay, here we go, moving forward. This one looks scary and I love it. Okay? Okay, this is one of the most common mistakes. My calculus students still make this mistake. And they expect you to make the same mistake, which is why it's a question on your ACT. So all they want to know is, what does that statement equal? So they've given you this statement. They want to know what it is equal to. Okay? There are two, maybe more than two ways that you could look at this problem. The first problem is you could do the math. Okay? And I'm going to show you a little quick way to kind of work through that and to make your life as easy as possible. Or two, you could go ahead and assign a number for X and Y. Make X 2, make Y 1, plug it in, and then see which numbers match. That doesn't make it that hard, okay? Not hard at all. So I'm seeing a lot of votes for A, which hurts my feelings, but it is what is expected. A is a trick. A is the mistake they are expecting you to make. Okay? So let's go ahead and just jump over to the whiteboard real fast. I've got to move stuff around. I got so much going on my screen. It's crazy. All right. Here we go. We are looking at 1/2 x minus y squared. If you use the guessing strategies, it's either B or C. I'm disappointed. Ryan, so disappointed. All right. Oh. Okay, we're going to FOIL. That means 1/2 x minus y times 1/2 x minus y. When we FOIL, okay, that's when we take 1/2 x times 1/2 x, and that's going to go ahead and give me 1/4 x squared. Okay? The trick that they're expecting you to do is they're going to assume you're going to go ahead and distribute that in, and it's going to give you 1/4 x squared plus y squared. Okay, how do I know to FOIL? Because 1/2 x minus y squared means this. And if that's what it means, that means we're multiplying these two terms together. So I'm just trying to match the terms. My first thought would be to FOIL that out. Okay, so we know it does not equal this guy, but we know the first term is 1/4 x squared. So let's jump back to our problems here. We know it's not A, but we know the first term is 1/4 x squared.
It's B.
And so the answer, it only has the one option, B. The cool part is, I haven't even done the problem. We did one step, and I found the answer. Am I going to go back and finish FOILing it out? No. Okay? To finish the problem, if you wanted to finish the problem, we would go ahead and we would keep FOILing. So I would get 1/2 x times negative y. Let me go ahead and clear this crazy screen up. So we had 1/2 x minus y, 1/2 x minus y. So when we FOIL, we're multiplying. 1/4 x squared, and then I'm going to get negative 1/2 x times y. And then I'm going to take negative y times 1/2 x, which is negative 1/2 xy, and then negative y times negative y, which is y squared. Combine the middle two terms because they both have the xy, and the answer is going to be 1/4 x squared minus xy plus y squared. Yep, you learned this in Math 2 if you have taken Math 2. First, outside, inside, last. Combine our like terms. But this, what we're looking at right now, this is what your math teacher wants you to show. Your math teacher wants to see every single step because we want to know if you get it. The ACT does not care. They want to know if you can find the answer. As soon as we found our 1/4 x squared, we knew the answer. So we were able to go back and we were able to pick our correct solution, B. Okay, so a little review there on FOILing, which is good. Make sure you know how to FOIL. And then, make sure you find the answer as fast as possible. You do not have to finish the full question. Okay, you never learned the FOILing, Quinn? I hope that little mini lesson helped. We'll see it again here in a bit. Guys, stop singing. Okay. This one's a busy problem. It's loud to look at and it hurts the eyes. But this question, I want you to find the answer. I do not want you to solve the problem. Okay? I want you to problem solve and find the solution to this problem in as little steps as possible. But you should not have to fully solve this before you find the answer. So take a few, look at it, see if you can even interpret all of that at once. So Quinn, to give you a little hint, you're trying to figure out what they have in common so we can divide it out, factor it out.
You add the roots, right? They're not multiplied. They're added.
Yeah,
Right.
you add them.
And I think you were talking about the powers, right? The exponents.
Yeah, like the 4,
Yeah,
the
right,
3,
that's what I meant.
the 2, those bad boys.
Yep. Okay. So I love the question from Belle. How are you guys finding the answer without solving the problem? What we do is we take one step and then we eliminate. Then we take a second step and we eliminate. So if we do the first step, 12, I keep pointing with my finger, thinking you guys can see what I'm looking at. 12, 30, and 24. Those three numbers are divisible by what?
6.
6. So that gets rid of D and E. So then we notice they all have 6, they all have X, they all have Y squared, but C has a Z in common. Do all three terms have a Z in common?
No.
No.
Nope. Middle term does not have a Z. So there's C is gone. Peace out. So this is the same. So now I look at the next one. 2. This one has a Y. This one has an X. So I come back up here. This has an X squared. If I factor out an X, should I still have an X left over?
It's A. Got it.
What are you talking about?
What's B, Luis?
Never mind. Don't read the chat.
It's B, bro.
It's
I was
B,
right.
bro.
Oh, broken. What am I telling myself?
Okay.
I'm like, it has to be B.
That is not the only way to find the answer on that problem. Okay? That is how my brain starts to eliminate. You can also look and notice other things, like we did not factor out a Z, but this third term's missing its Z now. So that's another way to get rid of A. Okay? Here, this has a Z cubed, and it's supposed to be a Z to the 4th. Somehow they've factored out that Z. Again, it's gone. There's lots of different ways that you could go through and you can find that elimination depending on what your eye is pulled to. Okay? Again, if I can emphasize anything that you learn in this class today, that is find the answer, do not solve the problem. I don't care what the answer is. I just want you to be able to find it as fast as you can. Time is money. Remember those $100 bills? We got to find them. All right. Man, whoo, time flew by. So let's push forward. Here's a nice problem. This problem we can use in multiple different ways. You can use one of the strategies that I've taught you. You could do the math if you know the math, straightforward math, or this could also be a time where you could bring your calculator into play. All you've got to do is you got to plug in a number for X and see if it matches what 8 cubed is. So I could quick ask my calculator, what does 8 cubed equal? and then I just got to plug in until it matches. Back solve, but let my calculator do the hard work. Okay, and Tristan's pointing out it is not D because D is the only one that's a decimal. So get rid of it. It's gone. This is an example where we can, if you start in the middle, it's going to help us eliminate. Dude, let's do a TED Talk about math. I don't think I'd get a lot of listeners. All right, we're getting a lot of votes for E. Okay. So if you start in the middle, say I started with 4, I plug that in, 2 to the 4th times 4 is smaller than 8 cubed, which means I need a bigger number. And we already said it can't be D, so then E would be my only option. So for those of you that have tossed out there the E, there we go. I'll quick walk you through the actual math on this one, just so you can see it. But I mean, you really don't even need to. Do you guys want to see it, or are you okay to move forward?
We're good.
No.
I want to see it.
All right, 2 seconds fast for whoever tossed it in there. It's really, really straightforward. Okay, so if we're looking at 2 to the, what is that? That is not me. Whee. Okay, 2 to the x times 4 equals 8 cubed. 4 is the same as 2 squared, and 8 is the same as 2 cubed. I don't know why that's getting weird, but that's okay. So what we're actually looking at right now, if they all have the same base, we're looking at x plus 2 equals 9. Okay, because these have the same base, we can add the powers, and then this is 3 to the 3rd, which is the same as 9. Now they all have a base of 2. The question is x plus 2 equals 9, which is 7. All right. Cranking forward because I didn't think we would have enough material, but now we have so much. All right. Common operation errors here. If we have the square root of 9 plus 4, is it the same as the square root of 9 plus the square root of 4? Luis, thank you for your answer. That top statement is not true. You cannot split a radical across addition. Okay? Okay, guys, let's focus. We only got so much time. Then we have the square root of 9 times 4 equals the square root of 9 times the square root of 4. Is that a true statement?
Yes.
Yes. Okay, so we can't split a radical over addition or subtraction, but we can split a radical over multiplication and division.
Yep.
All right. So with that in mind, we've got a practice problem.
Wait, could you go back there possibly for just a quick second? I was just writing it down real fast.
Okay, for this next practice problem, you can do the straightforward math. There are 2, maybe 3 traps, common mistakes they are expecting students to make. They're in the problem. Or if you are really good with your calculator, you could type it into your calculator and let the calculator do the dirty work. You just have to do some matching at that point. So let's take a look. So we've got this statement, and it wants to know what it's equal to. If you use your calculator is going to spit out a really crazy looking decimal, and then you're just going to have to match it to the decimal in the solutions. Okay? Plug it in, check it out. Plug it in, check it out. Or you can just do the math. Whatever your brain tells you to do. Chanel, I like how you're coming in with a question. Maybe? Yes, I can show you the math for this one, Tannen. I got you. Okay, again, I know that there are at least maybe only 2 traps on this one. I'm not sure. Maybe 3. There are 3. Are you sure? Oh, he's saying 3 is the answer, Isaac? 3? 3's 3? All right. I'm going to jump page here real quick.
Is never wrong.
Who's never wrong, Isaac? All right. So we have 16 root 10 minus root 2 times root 5 all over 5. So over here on the right side, we can multiply those together. So we're going to get, my computer's getting mad now, 16 root 10 minus root 10 all over 5. 16 root 10 minus root 10 is 15 root 10 over 5. And then at this point, we can only simplify the 15 and the 5. The 10 is protected by that radical.
Wait, how did you?
So we end up.
15? I'm sorry.
What was the question?
How did you get 15?
16 minus 1.
Gotcha. Sorry.
So if there's nothing
Oh,
there,
good.
just slap a 1 in front of it.
Absolutely. Yep.
Okay.
1s are always implied. Unless they're wrong.
Where's the 1?
Right here on the root 10. So just like we always see x by itself and we see y by itself, I could always say that's 1x and 1y, but the 1 is implied, so we don't have to write it. And it's the same thing we see right here on the 10. It's root 10, but there's 1 of them. Yep, it's usually there. We just don't have to show it because it's assumed. Okay. Cool. All right, so what I'm going to quick do, because we are now down to 13 minutes, and man, I was over ambitious and I thought we would have so much fun just doing so many problems. So I'm going to take a gander here. Oh, hey, look, we've only got a few left. No, we're good. I'm so solid. All right.
Stress, we're good.
Let's take a look at this problem, because I know you guys love it. All right. How many of you remember your complex numbers?
Kind of, but
I do. Kind of.
Of course.
Okay.
they're so complex, I kind of forgot.
Okay, so I is our imaginary number. I is just the square root of -1. So we know that I squared equals -1. If any of you guys have Texas Instruments, like a TI, like I think it's 84 or above, 83 or above, your calculator will actually do this problem for you.
It's a rip.
You just need to put it into complex mode. Okay, so if you have a TI, where do I want to go? Let's just exit full screen real fast.
How do you put it in complex mode?
I'm going to try to show you the best I can from a distance.
What if you have a TI 34?
I'm sorry, it's not going to assist you. Okay. Wrong one. That's my hangout and watching Netflix while I was working. Here we go. So if you have your 84, why is it not going to show me what I have pulled up here? Okay, so if you're looking at your 84 calculator, what you're going to do is you're going to go into mode, which is right here. You're going to scroll down, and you're going to see a place where it says A plus BI, or it's going to say complex. Right now it's in real. You're just going to toggle over to the A plus BI or complex. And it will type that for you.
At the bottom of the calculator for second, and for decimal in blue, this should be imaginary I.
I'm sorry, that was
Someone's
so
mic just
digitized.
broke.
Yeah, I have no clue what you just said.
Are you using Apple headphones?
Okay, but either or, if you have the TI or not, this is still doable by hand. Okay? Real straightforward, good times for math. 4 minus 2i times 4. Okay. 4 plus 2i. Woo. Once it's in complex mode, it'll still do everything else and it won't be a problem. And yes, you can solve any problem and you can do the ACT completely without a Texas Instrument or a calculator. Calculators aren't required. I had a buddy in high school, didn't even take a calculator in and pulled a 36. So, but you know, he's a genius and I was jealous. All right, this is another example of foiling. So 4 times 4 is 16. 4 times 2i is positive 8i. Negative 2i times 4 is negative 8i. Negative 2i times 2i is negative 4i squared. Okay, our middle terms cancel each other out. They reduce to 0.
Yep, combined like terms.
And then our I squared equals negative 1. So negative 1 times negative 4 is actually a positive 4. And our solution is 20. The I believe, I'm trying to remember, I don't have my calculator here, it's at school. If you look where the subscripts, the little letters, there should be a blue I down on the, like, yes, the decimal. Thank you, Lily. You're all over it. Thank you so much. Okay. We're kind of rushing through this problem. Apologize for that one. I have a second problem that is very similar to this one, but really what I want to just quick talk about is to make sure that you are comfortable with your calculator. We've got about 7 minutes left. I want to make sure that you guys know how to toggle between radians and degrees. Your calculator should be in degrees unless a problem is in radians. A radian looks like it has the pi symbol attached to it. Okay? If you don't know what any of that means and you don't care, there are only 4 trig problems on every essay or ACT. So if you miss your 4 trig problems, you can still get a 34 or a 35 on this test. So they're not make or break it. It's totally fine. Your fractions to decimals is a huge helpful hint if you were going to let your calculator do the dirty work for you, but then the answers that the ACT gives you is only in fractions. Okay. Depending on what your calculator looks like, go here, exit here. All of your calculators will convert your decimals to fractions and your fractions to decimals. So that's why I've pulled up my handy dandy calculators to kind of show you that. If you have a Texas Instrument that looks like this, you're looking for, can you guys see the mouse? So I'm highlighting where I'm looking at. Cool, thank you.
Yes.
This F to D right there, that's your fraction to decimal, decimal to fraction. So if you type in anything, you go ahead and hit that F to D. Okay? If you have the Texas Instrument, you come over here to math. You hit math, and the first thing that pops up says arrow to fraction. And then right below it, it says arrow to decimal. So if you're changing it to a fraction, hit 1, then hit enter, and it'll convert it to a fraction if it's a rational number. So those little button pushes can really help you save time if you're going to let your calculator do the dirty work for you. Earlier when we were talking about this TI-30XA, you have the F to D button down here at this arrow. So it's there to help you do the same. What about the button with the 2 arrow thingies? Which calculator am I looking at? Kristen? Is that this one? You have this one? XS. Ooh. So TI-30 XS, hit enter. Let's take a look at this beauty. Okay, I need one that's big enough I can look at. Come on, Amazon, help me out.
You should search up the TI-34.
I think with your calculator, this will convert you from exact to rounded, I think. So it'll convert from like a radical to a decimal back to its radical. It'll give you an exact answer. And no, it's a good button because it'll show you both really, really quick. The T34 doesn't exist.
Yeah, it does. Why do I have one?
I don't know. A TI-34?
Yes, it's a TI-34.
That's real old school looking.
Oh yeah, I've had this one since I was in like the 8th grade. It's an oldie.
So Kristen, that F to D, it'll convert anything from exact form to rounded form. So it's a pretty good button. It's helpful. All right, that picture, there we go. Yeah, that 34, you got the same buttons right there.
Yep.
And then your fraction to decimal is just your second up here.
Mm-hmm.
All right, we have 3 minutes, not a lot of time, but do any of you have any major questions that you want covered? Any thoughts, concerns, worries about the math portion?
We're
You guys
good.
feeling okay?
There's always those like couple of questions on the ACT where you're like, what in the heck is this?
Mm-hmm.
Like what about like they're like triangles and then they have like, I don't know, cosine, sine, tangent,
Mm-hmm.
all of that stuff. Like I don't know how to explain.
So anytime, like I said this a little bit earlier just about trig, cosine, sine, and tangent, that's all our trigonometry. You've got 4 questions. So if you don't know it, it's not going to hurt you in the slightest. Focus on what you do know and then move on from there. But if you pull up your book, there's a section that covers geometry. Your trig is going to be in there and it'll give you the basics because it's basic trig that's in there that's going to help you the most.
Okay, thank you.
Yep. Guessing. Oh, if you are just purely guessing, you're not going to use any of my strategies, pick one letter of the day and stick with it. So if you're just guessing to fill in a bubble, what was that?
What's typically the best letter?
B.
B?
B is just a hair used more than anything else. So if you stick with B, it's got like a 20.1% chance of being right. Yeah, don't forget to subscribe to Blondie and Glasses, my YouTube channel. I might go change my actual classroom YouTube channel to Blondie and Glasses. So see if you can find me. All right, guys, we did it. That was a lot of math in a short amount of time. Thank you for putting up with my weirdness and all my computer issues today.
I think you did amazing, didn't you guys? Really appreciate her. Thank her so much for coming today.
Fun.
Some great tricks.
I learned more than I did in my school's ACT prep, so.
Yay. So you guys, you have hung in there. You have one more session, so you can have a 10-minute break, and then we're going to come back and finish everything up in one sitting. We'll be done. Thank you so much, Melanie. Really appreciate you.
You're welcome. Good luck, guys. Remember, it is just a test. Go in super calm and chillaxed, and you'll do better than if you overthink it.
Yep. Okay. All right. Go take a break. Leave this room. Take a break, and then we will head back. Hey, thank you so much. Really appreciate your time and your knowledge and your skill in teaching and being here today.
Happy to help. It actually, with the whiteboard and toggling back and forth, it went way better than I was expecting. So
I was impressed. You did it. Now you know. I learned so much doing this. So maybe this is the way we're going to do it here really soon. So
it's not bad. And honestly, like with the chat system, I mean, I know they're goofing off and being kids, which is super entertaining, but I felt like the kids talked more and there was more interaction in a way. It was kind of nice.
Yeah, and fortunately, you were able to multitask and read the chat and still teach your lesson. That was impressive.
Yeah, it was kind of fun to just see everything pop up. Yeah. Some of those boys, very interesting.
Entertaining. Well, I hope you have a nice rest of your weekend.
Yep, you too.
All right, thanks, Melanie. We'll see you next week.
See ya. Mm-hmm.